We will probably unveil Optimus ER3 in a few months, and I think it's going to be quite surprising to people. It is an incredibly capable robot. Another major capability of Tesla Bot Gen 3 has just been strongly hinted at by Elon Musk as Optimus moves closer to real-world deployment. The picture of what this robot is truly designed to do in everyday life is becoming far clearer and more concrete. This time, we can finally answer a very specific question. What can Tesla Bot Gen 3 actually do beyond dancing all day? Stop looking for it on stage or only inside factories. Optimus is being prepared for far more practical work, cooking. As Jason Calacanis put it, greater than, and I saw Optimus 3, I can tell you now, nobody will remember that Tesla ever made a car. At first, we also believed this was just another case of hype. But Elon Musk himself shared videos of Optimus performing household tasks, including cooking, cleaning, and vacuuming, calling it the biggest product ever. The robot can be trained using internet videos to learn how to cook, operate a microwave, and carry out increasingly complex kitchen tasks, all aimed at reducing the everyday burden on families. Think about it. Chopping ingredients, stirring pots, washing dishes, handling wet food, managing timing, cleaning while cooking using a microwave, and performing complex kitchen workflows, or even working outdoors in the rain and assisting with pet care. It sounds like science fiction, but without the ability to cook or operate reliably in environments involving water and heat, a humanoid robot would remain little more than a novelty in the home, limited by the most basic constraints of the real world. So, how can Optimus actually handle household work? Let's break down what Elon Musk has revealed. In 2026, Elon Musk is making the boldest bet of his career and possibly the most consequential in modern technology. For the first time, Tesla is not merely expanding into a new product line. It is actively restructuring its core identity around a humanoid robot. The decision to halt Model S and Model X production and convert the Fremont factory into a dedicated Optimus manufacturing facility is not symbolic as operational proof that Tesla believes Optimus is ready to move from concept to real-world impact. Fremont is one of Tesla's most valuable industrial assets, and reallocating it to humanoid robot manufacturing indicates that Optimus is no longer experimental. This move reflects Tesla's belief that Optimus Gen 3 is mature enough to enter real-world deployment at meaningful scale, with production targets reaching 1 million units per year. Such a decision would be irrational if Optimus were limited to narrow industrial tasks or speculative future use. Elon Musk has emphasized that Optimus can acquire new skills by observing demonstrations, following natural language instructions, or even learning from video examples. This learning by observation capability is fundamental for household environments which are inherently unstructured and constantly changing. Unlike factories, homes cannot be pre-programmed. Tasks such as cooking, cleaning, assisting elderly individuals, caring for children, or handling pets vary from household to household and require contextual understanding rather than rigid automation. Optimus' adaptive learning approach directly addresses this challenge, making it far more suitable for domestic use than traditional robots. Tesla has confirmed that Optimus robots are actively working in Tesla factories, restaurants, public events, and company-hosted gatherings. These are uncontrolled human-populated spaces, not lab conditions. Tasks such as serving food, carrying objects, interacting with guests, holding microphones, and navigating crowds require advanced perception, balance, dexterity, and safety systems. This matters because household environments are even more complex than factories. Homes are unpredictable, cluttered, and designed for humans, not machines. A robot that can safely serve food at a public diner or interact naturally with crowds is already demonstrating the core competencies required for domestic use. One of the most critical barriers to real-world household robots has always been hands. Cooking, cleaning, caregiving, and pet care all depend on delicate, precise manipulation. Elon Musk has openly stated that the robot's hands and forearms are among the hardest engineering challenges comparable in difficulty to building the rest of the robot combined. The progress here is tangible. Optimus Gen 2.5 has already demonstrated fluid human-like arm and hand motion in public performances, including tasks that require balance and coordinated movement. Gen 3 is expected to take this further with hands that closely replicate human anatomy and motion. This level of dexterity is what allows Optimus to realistically handle tasks like chopping vegetables, loading dishwashers, assisting elderly individuals with mobility, or safely handling pets. Unlike single-purpose home appliances, Optimus is designed to use the same tools humans use: knives, pans, doors, switches, walkers, leashes. That design choice alone is a strong signal of real-world readiness. Elon Musk has emphasized that Optimus Gen 3 will no longer look like a robot. Instead, it will resemble a person wearing a robotic suit with concealed wiring, actuators, and joints, and movement so natural that observers may need to poke it to confirm it isn't human. This is not about aesthetics. It's about social compatibility. In households, especially those with children or elderly individuals, comfort and trust matter as much as functionality. A robot that moves smoothly, communicates naturally, and displays facial expressions via integrated displays is far more suitable for caregiving roles than a mechanical-looking machine. For elderly care in particular, psychological comfort is critical. A calm, predictable, human-like assistant can reduce anxiety, encourage cooperation, and provide companionship, something purely industrial robots cannot achieve. One of Optimus' most compelling real-world advantages is endurance. Elon Musk has highlighted that Optimus can theoretically operate 24/7, achieving up to 5 times the annual productivity of a human worker. While this is often discussed in an industrial context, its implications for home care are even more profound. Global populations are aging, and there is a severe shortage of caregivers. Optimus could function as a 24/7 in-home assistant, helping elderly individuals with mobility medication reminders, household chores, and emergency monitoring. Unlike humans, it does not experience fatigue, stress, or distraction, and it can maintain consistent performance throughout the day and night. For parents, this means reliable support watching over children, assisting with routines, and performing repetitive tasks without replacing human emotional bonds. For pet owners, it means feeding, cleaning, walking, and monitoring animals even when owners are away. Optimus is not a static machine. Tesla's approach allows robots to continuously learn and share data across a connected network. Every task completed by one Optimus unit can improve the performance of others. This collective learning system accelerates real-world capability far faster than traditional robotics development. In a household context, this means Optimus can adapt to individual preferences: how a family cooks, where items are stored, how a specific elderly person moves, or how a pet behaves. Over time, the robot becomes more personalized, safer, and more efficient. Tesla has repeatedly emphasized that Optimus will not be commercialized until it is proven safe. This includes strict grip strength limits, advanced object recognition, emergency stop capabilities, and controlled behavior systems. This focus is especially important for applications involving children, elderly individuals, and pets. A robot that can precisely control force, recognize fragile objects, and respond instantly to emergencies is far more suitable for caregiving roles than existing automation technologies. What has Elon Musk said about Optimus' next features as the launch of Tesla Bot? Optimus Gen 3 approaches the outline of what this robot truly represents is becoming unmistakably clear. What once appeared to be an ambitious side project is now revealing itself as a carefully engineered, real-world system designed to exist alongside humans. One newly confirmed feature, water resistance, may sound modest on the surface, but in reality, it fundamentally changes what Optimus can do, where it can operate, and whether it can ever succeed as a household robot. When Elon Musk recently confirmed that Optimus Gen 3 will more or less have water resistance, the response across the tech community was immediate. The reason is simple. Without water resistance, a humanoid robot is effectively confined to laboratories and controlled factory floors. With it, the robot can finally step into the real world, washing dishes, watering plants, rinsing food, mopping floors, bathing pets, working outdoors in the rain. These are not futuristic fantasies. They are basic requirements for a robot intended to function in everyday human environments. Water is everywhere in daily life: kitchens, bathrooms, gardens, sidewalks, after rain, snow, and winter. These are normal conditions for humans, but historically catastrophic for complex electronic machines. Optimus Gen 3's move towards strong water resistance is therefore not an optional upgrade. It is a foundational requirement. Without it, even a highly intelligent robot would be reduced to a fragile, expensive novelty. In practical terms, a $20,000 household robot that must constantly avoid water would be nearly useless. For most updates, that's fine. Improved motion control, better object recognition, faster learning, these are unambiguous improvements. But what about behavior? What about decision-making? What about privacy? If Optimus is learning continuously, what is it learning? If it's connected to a network, what data is being shared? If it's observing your home, your routines, your conversations, where does that information go? Tesla has stated that users control their data, that Optimus operates under strict privacy constraints, that all learning happens locally unless explicitly shared. These are important assurances, but they're also promises that depend entirely on Tesla's integrity and the robustness of their security systems. And here's the uncomfortable part. Once 1 million Optimus units are deployed, the incentive structure changes. A connected network of learning robots becomes an extraordinarily valuable data set. Not just for improving for understanding human behavior at scale, Tesla has repeatedly emphasized that safety is paramount, that Optimus will not be commercialized until it is proven safe, that hardware-level safeguards ensure humans remain in control. These commitments matter, but they're also being made before the technology is fully deployed. We don't yet know how these systems will behave in the real world. We don't know what edge cases will emerge. We don't know what happens when a robot trained on one family's routines is placed in a completely different environment. We don't know what happens when a software update introduces unintended behavior. These aren't hypothetical concerns. They're engineering realities. And they're the kinds of problems that only become visible at scale. So let's talk about scale, because that's where this story goes from interesting to genuinely consequential. Tesla is targeting 1 million Optimus units per year at Fremont. Gen 4 will be produced in Texas at significantly higher volume. Musk has discussed 10 million units for Gen 4, 50 to 100 million for Gen 5. If those numbers are even remotely accurate, we're not talking about a niche product. We're talking about a ubiquitous one. A robot that could be as common as a dishwasher, as normal as a smartphone. Think about what that means. In 10 years, there could be tens of millions of humanoid robots operating in homes, businesses, hospitals, and schools, all connected, all learning, all sharing information. That's not a product launch. That's a societal shift. And here's the part that nobody's talking about. If Optimus succeeds, it won't be alone. Competitors will emerge. China is already investing heavily in humanoid robotics. So is Japan. So is Europe. Within 5 years, there could be multiple manufacturers producing millions of units. The question isn't whether humanoid robots will exist. The question is what world we're building by deploying them at scale. There are legitimate reasons to be optimistic. An aging global population desperately needs caregiving support. There is a severe shortage of healthcare workers, childcare workers, and home assistants. Optimus could provide reliable 24/7 support for elderly individuals, reducing isolation and improving quality of life. It could assist parents with childcare, handle repetitive household tasks, and free up human time for creative, meaningful work. These are real problems, and Optimus offers real solutions. But there are also reasons to be cautious. A robot that operates continuously in your home observes everything, your routines, your conversations, your vulnerabilities. Even with strong privacy protections, that level of access creates risk. There's also the economic question. If humanoid robots can perform tasks currently done by humans, what happens to those jobs? Musk has argued that Optimus will create abundance, that it will free people from repetitive labor. But that assumes a smooth transition. It assumes that displaced workers find new opportunities. It assumes that society adapts quickly enough to avoid disruption. History suggests otherwise. Technological transitions are rarely smooth. They're often painful, uneven, and concentrated in specific communities. The people most likely to be affected by widespread humanoid robot deployment are the ones least equipped to adapt quickly. These aren't arguments against Optimus. They're arguments for thinking carefully about how it's deployed, for building safeguards, for ensuring transparency, for giving communities time to adjust. And that brings us back to the original question. What is Tesla actually building? Let's return to the water resistance, because it's easy to get lost in the larger implications and forget what makes this technology viable in the first place. Water resistance is not a feature, it's a prerequisite. Without it, Optimus cannot exist in the environments it's designed for. With it, the robot becomes practical. A sealed Optimus can wash dishes, it can mop floors, it can water plants, it can bathe pets, it can work outdoors in the rain, it can assist in bathrooms, it can handle the wet, messy, unpredictable reality of human life. And that's what changes everything. Because once a robot can survive water, it can survive most everyday environments. It's no longer fragile. It's no longer limited. It's no longer a novelty. Tesla's battery system is expected to follow the same design philosophy used in their vehicles. A sealed battery pack that prevents water intrusion even in high humidity environments. This protects the robot's energy source while enabling longer service life. The battery capacity for Gen 3 is expected to be around 3 kilowatts, enabling roughly 12 hours of operation. That's enough for a full day of household tasks. And because the robot can recharge overnight, it effectively provides 24/7 availability. Reliability under environmental stress is what separates consumer-ready technology from fragile prototypes. No one wants to babysit a robot by shielding it from rain or drying it off after minor exposure. Reliability also translates directly into economics. Water and humidity are leading causes of corrosion, short circuits, and mechanical failure. A tightly sealed Optimus Gen 3 will require less maintenance, experience fewer breakdowns, and remain operational for many years. This is essential if Tesla intends to price the robot below $20,000. At that price point, Optimus must deliver daily value, not constant repair bills. And here's what's fascinating. Tesla didn't start with water resistance as a design goal. They started with capability. They built a robot that could walk, manipulate objects, and learn from observation. And then they realized that none of it mattered if the robot couldn't survive the real world, so they went back. They redesigned the body. They sealed the hands. They relocated the act. They tested in kitchens, bathrooms, gardens, and rain. They treated water resistance not as a bonus feature, but as a fundamental requirement. That design philosophy reveals something important. Tesla isn't building a demonstration robot. They're building a deployable one. The rollout strategy reinforces this seriousness. Optimus Gen 3 will launch commercially later this quarter, but it won't be released to the public immediately. Throughout 2026, Tesla will deploy the robots internally, using its own factories as large-scale real-world testing grounds. This is a smart approach. Factories are complex, high-stakes environments. They're filled with machinery, people, and unpredictable conditions. If Optimus can operate reliably in a factory for an extended period, it's far more likely to operate reliably in a home. Public availability is expected in 2027. Once Tesla is confident that Optimus meets an exceptionally high standard, this timeline reflects a company that's prioritizing reliability over speed. That's notable, especially for a company often criticized for overpromising and under-delivering on timelines. It's also consistent with Tesla's broader strategy. When they launched Autopilot, they didn't release it to everyone at once. They rolled it out gradually, collecting data, refining algorithms, and expanding capabilities incrementally. Optimus will likely follow the same path. Early adopters will be Tesla employees, then selected partners, then controlled public releases. And finally, broad availability. This staged approach reduces risk while accelerating learning. And here's what makes this moment different from previous robotics efforts. Tesla isn't starting from scratch. They have decades of experience with autonomous systems, sensor fusion, real-time decision-making, and large-scale manufacturing. They've already solved many of the hardest problems. Optimus benefits from all of that institutional knowledge. The robot's AI is powered by Tesla's neural network architecture, the same systems that drive full self. The perception systems use cameras and sensors refined through millions of miles of real-world driving. The manufacturing processes leverage Tesla's automotive production expertise. In other words, Optimus isn't a side project. It's a convergence of everything Tesla has built over the last 20 years. And that's why the decision to halt Model S and Model X production is so significant. Tesla isn't hedging. They're not keeping vehicle production as a fallback. They're committing fully. That level of commitment is either visionary or reckless. We won't know which until the robots are deployed. Let's talk about what happens after deployment, because that's where the story gets complicated. Imagine it's 2028. Optimus has been on the market for a year. Tens of thousands of units are operating in homes across the country. They're cleaning kitchens. They're assisting elderly individuals. They're supervising children. They're walking dogs. And then something goes wrong. Not catastrophically wrong, just. For general household tasks, cleaning, cooking, laundry, Optimus competes with existing appliances. A dishwasher costs $500. A robot vacuum costs $300. A laundry machine costs $800 combined. That's still less than $2,000. So why spend $20,000 on Optimus? The answer has to be versatility. A single robot that can do all of those tasks, plus others, justifies the cost, but only if it actually works reliably. And that brings us back to the deployment challenge. Optimus needs to work well enough, consistently enough, to justify its price. Early adopters will tolerate bugs. Mainstream consumers won't. Here's what's fascinating. Tesla is betting that humanoid robots will follow the same adoption curve as electric vehicles. 20 years ago, electric cars were niche products. Expensive, limited range, impractical for most people. Today, they're mainstream, affordable, capable, and increasingly popular. Tesla's thesis is that humanoid robots will undergo the same transformation. Early versions will be expensive and imperfect, but over time, costs will drop, capabilities will improve, and adoption will accelerate. That's a reasonable bet, but it's not guaranteed. Electric vehicles benefited from a clear value proposition: lower fuel costs, reduced emissions, government incentives, improving infrastructure. Humanoid robots don't have the same tailwinds. There are no government subsidies for buying a household robot. There's no charging infrastructure to build out. There's no environmental benefit to emphasize. The value proposition is purely practical. Does the robot make your life better? If yes, you buy it. If no, you don't. That's a harder sell, especially for a $20,000 product that's unproven in real-world conditions. So Tesla needs to get this right. The first wave of Optimus units needs to work well, not perfectly, but well enough that early adopters become advocates rather than critics. Because if the first reviews are negative, if robots break down frequently, if they struggle with basic tasks, if they feel unsafe, the technology will face a credibility problem that could take years to overcome. On the other hand, if the first reviews are positive, adoption could accelerate quickly. People trust word of mouth more than advertising. A neighbor who raves about their Optimus is worth 1,000 promotional videos. Tesla understands this. It's why they're being careful with the rollout. Internal testing first. Controlled public releases second. Broad availability only after confidence is high. That's the right approach. But it also means the timeline is uncertain. Public availability might happen in 2027, or it might slip to 2028 or later. And every delay increases skepticism, because Tesla has a history of missing deadlines. Let's address the elephant in the room: Elon Musk's credibility. Musk has a track record of making bold predictions that don't come true on schedule. Full self-driving has been coming next year for nearly a decade. The Cybertruck was supposed to launch in 2021. It arrived in 2023. The Tesla Semi was promised in 2019. It started deliveries in 2022. So when Musk says Optimus will be available in 2027, should we believe him? The honest answer is maybe. Musk's predictions are often directionally correct, but temporally wrong. The technologies he promises do eventually materialize. They just take longer than he claims. So Optimus will probably happen. But whether it happens in 2027, 2028, or 2030 is uncertain. That matters because timing affects everything. If Optimus launches in 2027 and works well, Tesla establishes a massive first-mover advantage. Competitors are years behind. Tesla owns the market. If Optimus delays until 2030, competitors catch up. Chinese manufacturers, in particular, are investing heavily in humanoid robotics. Companies like Xiaomi, UBTech, and others are developing their own platforms. A 3-year delay could mean the difference between dominating the market and competing in a crowded field. So Tesla has strong incentives to move quickly. but they also have strong incentives to get it right. That tension speed versus quality is going to define the next 2 years. Now, let's talk about something that gets almost no attention in the press coverage. The supply chain vulnerabilities. Optimus requires rare earth magnets. These are essential for certain motors and actuators. And the vast majority of rare earth elements are mined and processed in China. China has recently imposed export restrictions on rare earth materials, citing national security concerns. Tesla has been negotiating with Chinese authorities to secure the necessary supplies. According to Musk, China's primary concern is military use. Optimus is a civilian product, so it shouldn't be affected. But geopolitics is unpredictable. If US-China relations deteriorate further, rare earth exports could become a bargaining chip. Tesla could find itself unable to source critical components. That's a real risk, and it's one that Tesla has limited control over. The company could diversify its supply chain, sourcing rare earth elements from other countries. But there aren't many alternatives. Australia, Canada, and the US have rare earth deposits, but they lack processing capacity. Building that capacity takes years and billions of dollars. It's not a quick fix. So Tesla is, to some extent, dependent on China's willingness to export rare earth materials. That's a vulnerable position. And it's not the only supply chain risk. Semiconductor shortages, shipping disruptions, and component failures could all delay production. Tesla has experience managing these risks. But Optimus is different from a car. The components are more specialized. The supply chain is less mature. The margin for error is smaller. One bottleneck could halt the entire production line. And given Tesla's ambitious targets, even a small delay compounds quickly. Here's what we're not being told. The real reason Tesla is rushing Optimus to market. The official narrative is that Tesla believes the technology is ready, that humanoid robots represent a massive market opportunity, that they want to establish leadership before competitors catch up. All of that is true. But there's another factor. Tesla's automotive business is maturing. Vehicle sales are still growing, but the growth rate is slowing. The market for electric vehicles is becoming saturated in wealthy countries. Competition is intensifying. Margins are compressing. Tesla needs a new growth engine, and Optimus is the most promising candidate. But here's the uncomfortable part. If Optimus fails, or even just underperforms, Tesla doesn't have an obvious plan B. The company has bet enormous resources, factory space, engineering talent, capital, credibility, and this technology. If it doesn't work, the consequences are severe. That's why the water resistance matters so much. It's not just a technical feature. It's a signal that Tesla is thinking carefully about real-world deployment, that they're not just building a demo unit, that they're serious about making this work. But it's also why the timeline is so aggressive. Tesla can't afford to wait. They need Optimus to succeed quickly because the company's future depends on it. And that creates pressure. Pressure to cut corners. Pressure to overlook problems. Pressure to ship before the product is truly ready. Maybe Tesla resists that pressure. Maybe their internal testing catches the critical issues. Maybe the technology really is mature enough for deployment. Or maybe we're about to see what happens when a company moves too fast. Let's shift gears, because there's another part of this story that deserves attention. The human element. If Optimus succeeds, millions of people will interact with humanoid robots daily. That's not just a technological shift, it's a psychological one. Humans have complex relationships with machines. We name our cars, we talk to our phones. We feel frustration when technology fails and satisfaction when it works. A humanoid robot intensifies all of those dynamics because it looks like us. It moves like us. It exists in our personal space. That creates opportunities for connection. A robot that provides companionship to an isolated elderly person could have profound emotional benefits. A robot that helps a disabled individual regain independence could be like, but it also creates risks, attachment, dependence, unrealistic expectations. If people start treating Optimus like a family member, what happens when the robot malfunctions? Or when it needs to be replaced? Or when Tesla discontinues support for an older model? These aren't hypothetical concerns. They're predictable consequences of deploying emotionally engaging technology. And Tesla is explicitly designing for emotional engagement. The human-like appearance, The customizable voice, the display that shows expressions, these features are meant to create connection. That's probably good for adoption. People are more likely to accept a robot that feels friendly and approachable. But it's also manipulative, because the robot doesn't actually care. It's a machine. It simulates empathy. It doesn't feel it. For most people, that distinction is obvious. But for some, especially children, elderly individuals with cognitive decline, or people who are socially isolated, the line between simulation and reality might blur. And that raises ethical questions. Is it responsible to deploy technology that exploits our social instincts, even if the outcomes are positive? There's no easy answer, but it's a question worth asking before millions of these robots are in homes. Here's another uncomfortable question. What happens when Optimus makes a mistake? Not a catastrophic mistake, just a normal one. It drops a dish. It bumps into furniture. It misunderstands a command. For most products, mistakes are annoying but manageable.